Okay, this is a video tutorial on how to derive the quadratic formula by completing the square. So we know that for any quadratic of the form ax squared plus bx plus c, we can always apply the quadratic formula in order to solve for x. Now what we're going to do though, in order to figure out where that came from, is we're going to complete the square here. So when completing the square, we're going to follow the same steps we normally would if we had just regular numbers here. The first step is always to move the constant term. So I'm going to subtract c first on both sides, and I end up with ax squared plus bx equaling negative c. Now my next step is always to factor out the lead coefficient of the quadratic term. So the lead coefficient here is a. So I'm going to factor out that a, and I'm left with x squared plus b over ax equaling negative c. Now the whole point of this is called completing the square. That's the next part I'm going to do. I'm going to create a number now to put inside here to complete this square. Okay, because right now it's not a perfect square. I want to create a perfect square. What I do here is take that term and I cut it in half. So that would give me b over 2a. The next thing I do to this term is I square it. So I take b over 2a and I square that, and I get b squared over 4a squared. So I now rewrite this left side as x squared plus b over b over ax plus b squared over 4a squared. Now, I can't just add something to the left-hand side without balancing my equation on the right-hand side. So I need to add another term in here. I can't just add b squared over 4a squared, though, because I'm actually adding a factor of a times that amount, right? So a times that amount. So let's figure out what that should equal. In this case, that a is going to cancel out down here, leaving you with the term b squared over 4a. Alright, now let me erase this a little bit. Okay, so now that we have that, where's my stuff at? Sorry. Okay, so now that we are left with that, I'm going to factor the inside. The inside of this is going to be x plus b over 2a. The reason why I know it's b over 2a is, remember, I created a perfect square. I create that perfect square by taking that number and cutting it in half. So that's where I'm coming up with b over 2a. That was the term that I created once I cut that in half. Alright, so the right-hand side, I'm going to simplify this and make this one fraction. So I'm going to turn negative c into negative 4a times c over 4a. Right? Plus b squared over 4a. And I'm just going to rewrite this a little bit cleaner here. So that's negative 4ac plus b squared over 4a. Okay, next step. I need to get rid of this term here because I want to isolate this x. So I need to get rid of that a. I'm going to divide that out. When I divide it out, it's going to go in the denominator over here and make that a squared. So now I have x plus b over 2a squared equaling negative 4ac plus b squared over 4a squared. Alright, one of my last steps here, almost done, is to take the square root of both sides. Now when you square root the left side, that breaks down into just x plus b over 2a. The right hand side becomes positive or negative, and the numerator here is super messy. You can't take the square root of that, so we're going to keep it like it is. The denominator, though, this can simplify to just 2a. So the square root of 4a squared is easy to do. We can make that just 2a. And now we have to subtract over this b over 2a term, so negative b over 2a plus or minus the square root of negative 4ac plus b squared all over 2a. Alright, this is getting really close to looking what we want it to look like. Now I'm just going to do some rearranging of terms. I'm going to combine our numerators and then rewrite the inside of our radical here. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is how you derive the quadratic formula.